Hey everyone, today we are going to solve the Daily LeetCode challenge of 20 March 2024, and the problem statement is merge in between linked list. So let us first understand the problem statement. So according to the problem statement, we have been given two linked lists, list 1 and list 2, and we have been given two integer variables a and b. Okay, and what does these a and b represent? These a and b represent the position of nodes. Okay, and what we have to do in this problem is we have to remove all the nodes from list 1 starting from position A to position B. And in that place, we have to insert this list 2. Now let's see what does it mean. So let me write down the position of each of the nodes of list 1. So this would be 0, 1, 2, 3, 4, 5. Okay. Now we want to delete all the nodes from 3 to 4. So what all are the nodes from 3 to 4? So we can clearly see that the nodes from 3 to 4 are 40 and 50. So what we want to do is we want to remove these nodes. Okay, that is we want to remove these two nodes, and in place of them what we want to do, we want to insert this list 2. So how would our resultant linked list look like? It would be 10, 20, 30, and after that it will have 15, 18, 22, 24, and after 24 we will have this 60. Correct? We will now what we want to do, we want to first delete this part. Okay, and after deleting this part we want to connect this list in place of these two nodes. Okay, now there are three things which we want to keep in our mind. First, since we want to delete all the nodes starting from this A, correct? Where is this A? This A is this 3, right? So since we want to delete all the nodes starting from A, how we can delete it? We can delete all the nodes starting from A by standing at this point, correct? That is by standing at the position 2, which is nothing but A minus 1. So what we can do, we can set the next of this 30 to list 2, correct? So if we will set the next of this 30 to list 2, then what we will get? We will get 10, 20, 30, 15, 18, 20, 24, correct? And what will happen? We will be able to delete all this part, right? We'll be able to delete all this part. But do we want to delete all these parts? The answer is no. We only want to delete this part, correct? We don't want to delete this 60, right? So what we will do is, we have noticed one more thing is that before deleting this part, we also have to store the entire part after this bth node, correct? So where is B? Here is B. So we need to store all the part after this B. So which part is there after this B? After this B, we have a 60, right? So we have to store this 60 somewhere so that we don't lose it, correct? So first point is that we have to reach to A minus 1 position. So we have to reach A minus 1 position in order to delete this part, correct? And another thing which we noticed is what? We need to store all the part after B, okay? Store the part after B, correct? So we need to store the part after B. Now, once we have got the part, say for example, the variable in which we have stored this A minus 1th position is from. So in from, we will have this node 30, correct? And say for example, we have stored the part after this B in another variable. Say for example, it's 2. So we have stored 60 in this 2, right? Now what we have to do is, we simply have to set the next of this 30. We simply have to set the next of this from as list 2, correct? So if we will do like this, then what will happen? Then this link, then the link between 30 and 40 will get broken, correct? And we will generate a new link between 30 and this head of the list 2. And what is the head of the list 2? The head of the list 2 is 15. So we will get this link and this link will be deleted, correct? Now, since this link got deleted, so what does it mean? It means that we have deleted all this part, correct? And what we have now, we have 10, 20, 30. After 30, we have 15, 18, 22, 24. Fine. But is this correct? The answer is no. Why? After 24, what we want? We want the 60, correct? So what we will do is, one more thing we have found out is that we have to reach at the end of the list 2. So what we have to do? We have to reach at the end of list 2, correct? So say for example, the pointer which is present at the end of the list 2 is current. So in current, what we will have? In current, we will have this 24, this node, correct? So what we can do now is, we can set the next of this 24 as this 2, correct? Because where is this 60 stored? This 60 is stored in this 2, right? So what we can do, we can set the next of current as 2. Fine. So this is 2. And we will be able to solve this, correct? Now let's quickly do a dry run so as to understood this in a better way. So initially we will take 3 pointers. First would be current, which will point at the head of the list 1. So what is the head of the list 1? We have 10. So what do we have in current? We will have 10. Okay, so let's write C. So the C represent current pointer. Okay, and we will have 2 other pointer from and to. So this from would be initially null and this 2 would be initially null as well. Now what does this from represent? This from will represent the node just before the node from which we want to start the deletion. So from which node we want to start deletion? We want to start deletion from the 8th node. Which is the 8th node? The 8th node is 50. And what is our from? Our from is the node just before this node. So which node is present just before 40? 30 is present just before 40, right? So what we will store in from? In from we will store this 30, okay? Because if we want to delete the part starting from this third index, so in order to delete it, we have to stand one index before it, right? So if we will stand at this 30, then only we can set the next of 30 as list 2, correct? So we will store the node just before the 8th node in from, okay? And what we will store in this 2? In this 2, we will store the node after this B. So where is B? B is at 4. That means that B is this 50. So what we will store in this 2? We will store 60 in this 2. Why? Because if we will set the next of 30 to list 2, then what will happen? Then this entire part will be deleted. But do we want to delete the entire part? No. We want to delete only this part and we want to preserve this 60. So what we will do? In order to preserve it, we are storing it in the variable 2. Correct? So in from, what we will be storing? Let me write over here. In from, we are storing node just before A. Correct? Just before A. The node which is just before A, we are storing it in from. And in 2, what we are storing? We are storing the part after B. Okay. So let's see how we can solve this. So we will take a pointer I, which would be initially 0, and we will say that while this I is less than equal to B, what we will check? We will check if I is equal to A minus 1. Why? Because we want to reach the A minus 1th position, correct? And once we will be reaching the A minus 1th position, what we will do? We will store this A minus element present at A minus 1 position in the from, correct? So what we will do? We will store current in from, okay? Now, if this I equals to B, in that case, what we will do? In that case, we will store current in 2. Why? Because what does this 2 represent? This 2 represent the part after B. Okay. So whenever we will reach this position, that is I equals to B, we will store it in 2. Correct? Then what we will do? We will simply move the current pointer ahead. That is current is equal to currents next. Okay. Now let's quickly see this. So initially our current pointer is at the head, that is at 10, and I is 0. So what we will do? We will check that is this I less than equal to B. What is B? B is 4. And what is I? I is 0. So 0 is less than equal to 4. Now we will check that if I is equal to A minus 1, what is A? A is 3. So what would be A minus 1? A minus 1 would be 2. So is I equal to 2? So I is not equal to 2. Is I equals to B? I is not equals to B. So what we'll do is simply set current as the next of current. So our current pointer will now come over here. So what we have in current? We have 20. Okay. And what we will do? We will also increment this ith pointer. So now the value of I will be 1. Correct? Now we will again come in this while loop. What we will check? We will check that is I less than equal to B. So I is now 1. So is 1 less than equal to B. So 1 is less than equal to B. Now we will check. Is this I equals to 2? So I is not equals to 2. Now we will check. Is this I equals to B? What is B? B is 4. So I is not equals to 4. So what we will do? We will move the current pointer. So our current pointer is now at this place. So we will have 30 in our current. Okay. And we will increment I. So I will become 2. Now we will check, is this 2 less than equal to 4? So 2 is less than equal to 4. Now we will check if I is equal to A minus 1. So what is A minus 1? A minus 1 is 2. And what is the value of I? We have 2 in I, right? So what we will do? We will set from as current. So what we will store in from? In from we will store current. What is current? Current is 30, right? Current is pointing at this node. So in from we will store this node 30. Okay. And what does it mean? It means that we have reached the A minus 1th position. Correct. So since we have reached this A minus 1th position, we will store it in from, because from this node only we will start the deletion, right? So now what we will do? We will set current as the next of current. So current will now point over here. and we will increment the ith pointer. So the ith pointer will now become 3. Okay. Now what we will check? We will check that is this 3 less than equal to 4. So 3 is less than equal to 4. So what we will do? We will check this condition. So we will check, is this I equals to a minus 1? So I is not equals to a minus 1. Now we will check, is this I equals to b? So I is not equals to b. Why? Because I is 3 and b is 4. Correct. So what we will do? We will move the current pointer. So the current pointer is now pointing at 50. Okay. So the current pointer was previously 40 and now it is pointing at 50. Fine. Now what we will do? We will also increment the ith pointer. So the ith pointer will now become 4. Okay. Now what we will check? We will check that is this I less than equal to b. So we have I as 4. Correct. So is this 4 less than equal to 4? So 4 is less than equal to 4. Correct. Now what we will do? We will check this case, that is this I equals to a minus 1? So I is not equals to a minus 1. Now we will check, is this I equals to b? So what do we have in I? We have 4 as I, and what is b? B is also 4. So I is equals to b. So what we will do is, so where is our current? Our current is present at 50, right? And what do we wanted to store in 2? In 2, we wanted to store the part after b. So what we need to store over here? We need to store the next of current. Correct. Because current is where? Current is present at this 50, right? And what do we want? We want the part after b. So what is the part after b? This part is after b, right? So what we will store in 2? In 2, we will store the next of current. So current is at 50, and what is the next of current? The next of current is 60. So what we will store in 2? In 2, we will store the node 60. And after that, what we will do? We will move the current pointer forward. So our current will now point over here, okay? And we will increment the ith pointer. So the ith pointer will become 5. Now we will check, is our I less than equal to b? What is I? I is 5. Is it less than equal to 4? So it's not less than equal to 4. So what does it mean? It means we will come out of this while loop. And till now, what have we found? We have successfully found out from, and we have successfully found out to. Okay. So now that we have found out from and to, what we will do? We will now start the deletion. So let's see how we can do it. So we know that from is at 30. Correct. So what we can do is, we can set the next of from. We can set from's next as list2. Correct. So if we will do like this, what will happen? We will delete all this part. Correct. We will delete all this part. That is, this link will get broken and this all part will get deleted. And what will happen? It will create a new link that is after 30. What we have done? We have set the next of from as list2. So what we will have? We will have 15, 18, 22 and 24 over here. Correct. But is this correct? It's not correct. Why? Because we didn't wanted to delete the part after b, right? B was here. Correct. B was here. And we didn't wanted to delete the part after b. That is, we didn't wanted to delete the 60. So what we will do? Where have we stored the part after b? We have stored the part after b in 2. So what we will do? We will now set the next of this node as 60. But do we know the next of this node? So the answer is no. So how we can do it? We can set the value of current. So currently our current pointer is pointing at 60. So what we will do? We will reinitialize the current as the head of list 2. So what is the head of list 2? The head of list 2 is 15. So current would be at 15. Now what we will do? We will say that until the next of current is not null. We will say that while current's next is not null, what we will do? We will move current. So we will see that is the next of current null. So the current's next is not null. So what we will do? We will move current. So current is at 18. We'll check that is the next of 18 null. So the next of 18 is not null. So what we'll do? We'll move current. So current would now point at 22. Now we will check, is the next of 22 null? So the next of 22 is not null. So we will now move the current pointer. So current will now point at 24. Now we will check, is the next of 24 null? So we can see that the next of 24 is null. So what will happen? We will come out of this while loop. Now, the moment we have come out of this while loop, so where is our current pointer? Our current pointer is at 24. Correct? Here is our current pointer. So what we can do? We can simply set the next of current's next as 2. So what will happen? Here is our current pointer. So what we will have? We will set the next of current as 2. What we have in 2? We have 60 in 2. So we will have 60 over here. So this is our new linked list, that is 10, 20, 30. Then after that we have 15, 18, 22, 24 and 60. And we have successfully removed all the elements starting from the position 3 to the position 4. And we have inserted the list 2 in its place. Correct? So I hope it's clear to you all. So let's quickly code this. So let us create 3 pointers. The first pointer would be current, which will point at the head of the list 1. So we have list 1. And the another pointer would be from. So initially it would be null. And why are we using this from? We are using this from to store the a minus 1th node, correct? We want to store this node. And why do we want to store this node? It's because see that what is the ath node? The ath node is 3, correct? The ath node is 3. And what we are storing in this from? In this from we are storing a minus 1th node. That is this node. And why are we storing this? Because by standing on this node, we will able to delete all the part after it, correct? That's why we will be storing it in from. And what will be the another pointer? The another pointer would be 2, which would also be null initially. And what we will store? We will store part after B, correct? Why we want to store the part after B? Because if we will set the next of this from as list 2, then what will happen? The entire part after this from node will get deleted, correct? It means that we will be also deleting the node after the bth node. But do we want to delete the node after the bth node? No, we want to preserve it. And what we want to do? We want to link it at the end of the list 2, correct? So that's why we will be storing it in the 2 node, correct? Now what we have to do? Now we have to take an ith pointer, which would be initially 0, and until this I is less than equal to b, what we will do? Let's take the ith pointer initially as 0, and until this I is less than equal to b, what we have to do? We have to check if this I is equals to a minus 1. Why a minus 1? Because we want to reach a node before the ath node in order to delete it, correct? If this I is equal to a minus 1, it means that we have got the from node, so we will store from at as current, okay? Now, else if we will have this I equals to b, then what does it mean? It means that we have reached the bth node. So what we want? We want to store the part after the bth node in the 2 pointer, correct? So we will store currents next in 2, because what does this means? It means that once we have reached b, it means that our current is pointing at the bth node. And what we want to store in 2? In 2, we want to store part after b. So which will be the part after b? It would be the next of current, right? And what we have to do? We have to set current as the currents next. That is, we are incrementing our pointer. We are moving our pointer forward, and we have to also increment I. Okay. Now, once we are done with this while loop, what does it mean? It means that we have successfully found out this from and this to. Okay. Now, what we want to do? We want to find out the end of the list 2. Now, why we want to find out the end of the list 2? Because at the end of the list 2, what we want to add? After the end of the list 2, we want to add the part after the B, right? After the bth node. So what we will do? We will set current as the head of list 2. That is, we will set current as list 2, and we will say that whilst current next is not null. Correct. Whilst currents next is not null, what we will do? We'll simply increment current. Current equals to currents next. Okay. Now, once we will complete this while loop, what will happen? Where will this current pointer point? This current pointer would be pointing at this 24. That is at the end of the list 2. Now, what we want to do? Now, we simply want to set the next of this from as list 2. So, what we want to do? We want to set froms next as list 2. So, what we have done? We have successfully deleted this entire part. Okay. Now, what we want to do? Now, we want to set the next of the end of list 2 as this 2, correct? Why? Because in this 2, we are having the part after the bth node. So what we will do? We will now set the next of currents next as 2, correct? Now what we'll return? We'll simply return list 1. So let's run this. It's giving us the correct answer. Let's submit it. And it got accepted. Talking about the time complexity and space complexity. So if there are n nodes in list 1 and if there are m nodes in list 2, then the total time complexity would be order of n plus m. So let us see why is it. Okay. So here what we are doing, in this while loop, we are iterating over the list 1, correct? In order to find the a minus 1th node and the bth node. Now at the worst case, what could be the value of this b? The value of this b could be the second last node, correct? Because in the constraint, we can see that what is this b? This b is less than equal to len dot size minus 1, correct? So what does it mean? It means that in that case, we would be like ending up iterating over the almost entire, all the n elements of list 1. So what would be the time complexity over here? It would be order of n, correct? And what we are doing in this while loop? In this while loop, we are iterating over the entire list 2 in order to find its last node, correct? So it means that we'll be iterating over all the m elements. So what would be the time complexity? It would be order of n plus order of m, correct? And we are not using any extra space from our end. Therefore, the space complexity is order of 1. So that's all about today's daily LeetCode challenge. Thank you.